Hello friends, very good morning. Today I would like to enlighten you regarding the firmware development for automotive applications. Before we step into the details of the firmware development, let us understand what is the firmware and what's the difference between firmware and software. Firmware is also a software, but usually we use this word firmware once you develop the software for embedded systems. What is an embedded system? Embedded system is a combination of hardware and software. So the software, which is an application that we develop, will be stored in a memory called flash memory that we find on a microcontroller. This microcontroller can control the operations as we desire. So the firmware is a piece of software, but as it is firmly stored on the flash memory, the same software runs on a larger system forever. Then that's why we call it as firmware. So it's a software, right? Firmware is a software. And what are the applications of these embedded systems? Embedded systems find applications in consumer electronics, automotive applications, and networking products, and so on. So the embedded system is inserted into a larger system here, like home appliances. If you take, there is the refrigerator, washing machine, microwave oven, and other home appliances, larger systems are there. Into that we insert this microcontroller or embedded system to perform certain operations as we require. So when it comes to the firmware development for automotive applications here, firmware development stages I would like to explain today. So the first step in developing the firmware or software for automotive applications is we need some requirements here. So both software and hardware requirements. What are the hardware requirements for developing the software? We need a microcontroller here. Microcontroller is simply called as a mini computer. Mini computer. Basically, you know that computer has a central processing unit, or simply called as processor. Along with that, there will be two types of memories. One is called as primary memory, another is secondary memory. The example of the primary memory is random access memory, RAM. As you know, the purpose of random access memory is to run the programs. Any program, if you want to run here, then it first find the resource called random access memory. Without that RAM, you cannot run the programs in any system, either it is the desktop system or laptop or a mini computer or a workstation, or it can be a supercomputer. So where the programs run, it is the random access memory, which is the primary memory. While the use of secondary memory is what are the programs all you develop and your text files, other data can be stored in the secondary memory. The examples of secondary memory: hard disk drive HDD, and also the floppy disk, compact disk, pen drives. These are all secondary memories. So along with these memories, the processor and also some IO devices here. Let us take mouse as an input device. Keyboard is an input device. Monitor is output device. So these are the IO devices, which is the third requirement for building a small computer or mini computer here. And along with this, we need some extra peripherals and extra memory also here that we can connect as per the requirement. But minimum things required are these here. One processor is required, along with that memories. The memories are again of two types: primary memory and secondary memory. And also some IO devices to have the user interface like mouse, keyboard, monitor, like that, right? So these are the hardware requirements here. Then what are the software tools and software libraries that we require to develop this firmware or software for automotive applications? We need an integrated development environment. The first tool that we require is IDE, stands for Integrated Development Environment. So what does it contain here, IDE? IDE is the one where different tools for development of software or application are available. To start with, of course, there is editor, of course, to edit the program and to compose the program and to have the visual inspection of the code here, the editor can be used. And after editor, we need a compiler to compile the program. Of course, you may be writing the program in C language or C++ or Python. Whatever may be the language in which you write the program here, compilation or interpretation is the important stage here. If it is Python program, we use the interpreter. If it is C++ programs, then we use compiler. So this compiler is also there in the integrated development environment in order to compile the program and thereby generating the executable file or binary image. That is the second one. But in the after compiling and generating the executable file here, we don't want to run this program on the system where it is developed, but we want to upload this program or port this program or load this program onto the flash memory of the microcontroller or embedded system. Flash memory is a secondary memory. There it runs here. That means development is on one system and while the application is running on a different system. This type of development is called as cross-platform development. That means the software is developed on, say, a laptop or desktop here, while it is running on a different hardware architecture and with different operating system or libraries called microcontroller. So microcontroller is one where the program runs, while laptop or desktop system is one where we have developed the program. So this kind of environment is called as cross-platform development system here, right? So then after developing the program, and of course before you flash the code onto the flash memory of the microcontroller, one step you must not forget, that is the debugging the code here. Without debugging, you should not flash the code onto the microcontroller, because bugs have to be removed here. The debugging is a process where bugs can be identified and they can be removed, or we mitigate the solution for the bugs here, right? So debugging means we again need a certain tools there, and if it is integrated development environment IDE we talk about, then debugger is also provided as one of the tools here. Along with editor, compiler, we also have the debugger here. So some examples for debugger are like GDB. GDB stands for GNU Debugger from Linux, which we can use to debug the code, and we can step into some functions, and you can step over the functions to certain instructions and then inspect those instructions and check the variable values. All these kinds of thorough checking we can do, and thereby we can identify the mistakes or bugs in the program. And once you trace that bugs here, the next step is to mitigate the solution so that the debugging process can be over. Once the code is debugged and it's running perfectly, then you can port that code onto the flash memory of the microcontroller. Then the embedded system is now ready, of course, to run to do the job here according to the instructions that we stored on the flash memory here. So after delivering this product to the customer or client, this particular firmware here, if they come back, of course, with some issues there, then we must have the maintenance and support unit here who will take care of again tracing out the problem with the software or firmware and rectifying that up to the satisfaction of the client or customer. So these are the some important fundamentals. How can we develop the firmware or software for automotive applications? Now we shall throw a light on also the different methods of firmware development when it comes to the tools that we listed out here, like integrated development environment, which contains like compiler, editor, debugger, and also loader here. Loader or programmer is another tool the integrated development environment provides. So this loader obviously loads the program onto the flash memory of the microcontroller. Therefore, you can run that program on the microcontroller or embedded system, right? So these are the different tools which are integrated into one application called integrated development environment. To sum up here, IDE is tool here, software development tool, which contains the code editor and where you can compose the code and edit the code, and compiler or interpreter here, which will convert our source code into the object code or executable code here. And after that we will debug using debuggers like GNU debugger, GDB, or if you use like ST microelectronics in IDEs here, there they provide the ST-Link debugger, or JTAG based debugger can also be used, right? So after debugging and once the bugs are removed from the code, then you are now free to flash that code onto the flash memory of the embedded system, which will be inserted again into the larger system like car. Now automotives means car, vehicle, other vehicles like trucks, all those things into that. So according to the instructions that we stored on the flash memory, one by one the instructions get executed, then functionality can be realized eventually. Now let us talk about different methods by which the firmware can be developed with the help of this IDE. There are obviously three methods here. The first one is bare metal programming. As its name implies, bare metal programming is one where we don't use any libraries or we don't take the help of real-time operating system. Usually we use the operating system in embedded systems that is not a general purpose operating system, rather it is a real-time operating system. That because these are all real-time applications here, whereas the applications that we run on general purpose systems like desktop, laptop, workstation and other big computers are the general purpose applications here. So the difference is a real-time application is one where the application has to finish the job on time here without any delay. So the job has to be performed at an instant of time t1 here, exactly at that moment the job has to be done, neither before that instant nor after that instant. So that is called as that instant of time t1 is called as real time. So once you develop the applications, you making use of this RTOS, real-time operating systems, then we call that application as real-time application, and the embedded system in which use this application is called as real-time embedded system. Real-time embedded system. So in the bare metal programming method, of course, we don't use libraries or any real-time operating system. Directly we try to access the hardware here. Directly we try to access the hardware with the help of registers. No assistance from libraries or any operating systems here. Then if you develop the program like that, making use of reference manual or related to that microcontroller or the evaluation boards available from different vendors like ST Microelectronics, Microchip is another vendor, PIC microcontrollers are there, Arduino microcontrollers are there, like the different vendors are there, and different vendors will offer different microcontrollers with different configurations here. There may be some single core process and there may be some multi-core process here. So accordingly you can also execute the programs concurrently with the help of multi-cores like dual core, quad core, octa core, like that. Different microcontrollers are available from different vendors. So once we use a particular microcontroller from a particular vendor here, then we have to go through the reference manual and data sheet provided by that vendor to program that microcontroller, especially when you are taking this type of development called bare metal program development, because there is no assistance from either libraries or from operating systems. Then you have to access the pins to which the peripherals are connected, and also to which pin a particular peripheral is connected. How can we access that pin? Which register has to be written, or which register has to be read from? Of course, this kind of details are available in the data sheet of that microcontroller or reference manual of that microcontroller. That's why these documents you must understand, and then will be in a position to program that microcontroller without the help of these libraries or real-time operating system. That kind of programming model is called as bare metal programming, which is just like a device driver development. If you talk about what are the devices or peripherals that we connect to the computer, or like mouse is a peripheral we connect to the computer, keyboard is another peripheral, monitor is another peripheral. Every device you connect externally to a computer requires the software called device drivers. Without the device driver, the operating system even cannot access the hardware, it cannot communicate with the hardware. That means obviously there will be 3 4 layers in this computing system. The top layer is nothing but application layer, and below that you will find operating system. The role of operating system is to provide the interface for the user so that user can access through this OS the hardware and get their job done, of course. Even operating system cannot directly access the hardware, the underlying hardware, but it takes the help of device drivers here. So this device driver development is just like the bare metal programming model what we just now discussed. That means with the help of the reference manual, data sheet and user manuals and additional documents which are provided by the vendor to program that particular, programming manuals may also be there to program that particular microcontroller, and through the registers, and which can be of course accessed once you trace out that particular register from these manuals in order to have the access to the different pins to which the peripherals are connected. Peripherals are nothing but in the case of microcontrollers we have the peripherals like light emitting diode, which is an output device, switches which are called as input devices, push button switches which are called as input devices, and also we have the speakers as well as microphones, some sensors like temperature sensor, humidity sensor, altitude sensor, smoke sensor. This kind of sensors are also categorized as some peripherals here. So all these peripherals can be connected to this microcontroller to certain pins there, and that pins we can access through the registers. That register information is available in the reference manual, data sheet, user manual associated with that particular microcontroller on which we are developing the program with the help of IDE, integrated development environment. This is the first model and a bit more critical because we don't have the assistance from the libraries or the operating system. But whereas the second model is little bit easier because where we take the help of the libraries like HAL, hardware as abstraction layer, which is one of the libraries available, and through that we can make the code development easy, of course. We can also use CMSIS, SIMSYS libraries here, CMSIS. So through these libraries also you can have some functions and that can be called to execute the job here, rather than developing each and everything on your own by accessing the hardware directly through the registers. The third and important model of developing the program is using RTOS. RTOS stands for real-time operating system. So usually with general purpose systems we use GPOS, whereas with real-time embedded systems we use RTOS. There are certain differences between GPOS and RTOS. General purpose operating system finds ample amount of resources like processor speed, memory space, and also the other peripherals which are required in developing the applications. But whereas these resources are minimal, of course, even power is also good enough, of course, for general purpose systems. You need not to worry about the power supply to the particular general purpose computing system. Whereas there are some constraints on the embedded systems. We cannot use resources so liberally as we use with general purpose systems. Processor speed is limited, memory space is limited, and there is power constraint also. Under these constraints or in this environment, constrained environment, we have to build the applications. That is very challenging to develop the applications for embedded systems because under the constraints, power constraint, memory space constraint, and processor speed, we cannot use high profile process because we are embedding this small microcontroller into a larger system. If this particular microcontroller itself costs very high, then the larger system cost will also go high. Then we cannot satisfy the customers once the price of the product that we are going to deliver is high, right? So that's why we must build these microcontrollers with minimal resources. So under these constraints, as we have to develop the programs, therefore this is a little bit critical and very involved one here for the developers. And also testing must be there, of course, which is very crucial in embedded systems. Every product that you develop, software product and also embedded system product here, has to be thoroughly tested, and then only you are allowed to release the product into the market. And thereafter, of course, there may be maintenance and support through which you can address the issues posed by the customers. But that is a different scenario. Before you deliver the product or before you release the product here, definitely the product should undergo the quality analysis department here, where they do different types of testing, like integration testing, regression testing, and customer satisfaction. Final In the presence of customers, they also do the testing here. They demonstrate how the product works. All these things will happen in the quality analysis department. And of course, as part of development, also developers will do certain testing called the white box testing here. So this kind of testings have to be happened, and you have to make sure eventually that product is working fine and it is ready to release. So like that, three different development procedures are there by which you can develop the firmware or software for the embedded systems in different applications like consumer electronics, automotives, network products, and even aviation applications also, which are namely the bare metal programming method, and the second one is making use of libraries. Here you can make the programming simple, or coding becomes quicker and easy. And even third and last one is the using real-time operating systems like FreeRTOS, QNX, VxWorks. These kind of operating systems are available, and some of the operating systems are free to use and some require license you have to purchase here. So you can choose depending upon your requirement, either free operating system or the paid operating system. So then you can make it tailored for your application, so that the real-time operating system also fit in the flash memory along with your application and run hand in hand to execute the job. So to sum up here, automotives applications always find this the embedded systems or the microcontrollers to control the operations and to automate the different operations in the automotives like cars and trucks and other vehicles. So in developing this software, which we also call as firmware, we need certain tools like the integrated development environment, as well as some debuggers, and additionally we also require some testing tools. And apart from the software tools here, we also require some hardware tools like the microcontrollers, which are being developed by different vendors here. And as per our application, we have to choose the particular microcontroller with desired configuration. But remember that these microcontrollers have three important constraints. One is the power, second one is processor speed, third one is the memory space here. Under this constrained environment, you have to develop the programs, and that can be compiled and then debugged, finally programmed or loaded onto the flash memory of the microcontroller, which will be inserted into the larger system to realize the operations required. Hope you understood the importance of the firmware development in automating the processes in different types of appliances. Either it can be the home appliances, or like consumer electronics, or it can be automotive applications or aviation applications. Everywhere nowadays we find these embedded systems where firmware has to be developed to make the process automated. So that's it for today, and thank you.